Hi guys, this is Mr. Urrego, and today we're going to solve inequalities. We're going to solve them, graph them, write them in interval notation and set notation. So let's start. We're going to start from the very basic. So let's say that I have x is less than 3. By the way, let's talk about the symbols. This is read less than, okay, less than. Here we have an equal underneath, so this is less than or equal to. Greater than or equal to. So when you have the line underneath, I'll use it as an equal. So less than or equal to, greater than or equal to. My first one, x is less than 3. So let's graph it. I'm going to have my number line. Okay, I'm going to put my 3 here, my 0 will be here. You don't have to put at 1, 2, 3, you know, every single one of them. You want to know where the 0 is located. And now, let's think, x is less than 3. So any values that are less than 3. So, two things. When I have the equal sign, right, this is going to be a shaded dot on my number line. When there's no equal, it's going to be an open dot. Alright, same thing here. No equal, open dot, equal, solid or shaded dot on my number line. So in this case, I don't have the equal, therefore it's an open dot. X is less than 3. All the values that are less than 3, 2, 1, 0. So my graph is to the left. I make sure that I nice arrow right there. So this is my graph of my inequality. Now I'm saying write them in interval notation. When I'm writing the interval notation, I'm going to have two parentheses. I can have a parenthesis and a bracket. Then I can have two brackets, or I can have or bracket and a parenthesis. I can have any of these four options. Alright, with the comma in between. That's my interval notation. The number that goes on the left is the smallest number. Smallest number. The number that goes on the right is the biggest number. Okay, smallest number, biggest number. In all of them, left side, smallest, right side, biggest, on every single one of them. Now, I'm thinking here, what is the smallest number that I can have on this inequality? My arrow is going to the left, so infinity. I don't know which is the smallest number that it can be, so I start at negative infinity. And the highest number will be the 3, not including the 3. So, negative infinity, that's my smallest value. And always infinity or negative infinity, I use parentheses, comma, 3. Because it's not included, I put in parentheses. If I had an equal sign, then it would be bracket. So let's continue over here. So less than, open circle, parentheses. Less than or equal, close circle, bracket. Okay? Open circle, parentheses, close circle, bracket. That's how it goes. Now, some graphs on some textbooks, they like to have, instead of the open circle or closed circle, they like to have the parentheses or bracket. So I can also graph this using a parenthesis, and my graph is to the left. So I can have an open circle or a parenthesis for this inequality. Okay, so now I have my graph, my interval notation, my graph in two different possible different ways, but I also say set notation. So set notation is nothing else than I start with a brace x such that, and then here comes my inequality. Whatever I have on my inequality, and let me bring that with red, whatever I have on my inequality comes next on my set notation. Okay, so I start with brace x such that, and I bring my inequality, x is less than 3, and then I close my inequality, my brace. Alright, let's go back to, and this is set notation, and it's read all the numbers such that x such that x is less than 3, x such that x is less than 3. Okay, Let me say that again. The set of all x such that x is less than 3. Alright, that's the proper way. I was going too fast over this. So the set of all x such that x is less than 3. Alright, so that's the proper way how to read this. So this is set, and by the way, set notation is not, it's set builder notation. Set builder notation. Alright, it's more proper. So the builder goes over here. Alright, so let's work on another example. So we have now 3x plus 4 greater than or equal to 10. The idea is to solve for x, graph, write interval notation and set notation. So let's solve. When we solve an inequality, it's the same thing as solving an irregular equation. We need to leave the x by itself, cancel the 4, minus 4 minus 4. So I have 3x, greater than or equal to 10 minus 4 is 6. What is multiplying the x? Divides by 3 on both sides. X is greater than or equal to 2. Now my x is by itself. We need to graph. We always graph. So we place the 2 some here. The zeros are going to be on the left. Now let's read from the x. X is greater. It has the opening. X is greater than or equal to 2. So I come over here and make a circle. Greater to the right. But now I need to define, or I need to make sure that I know. I have x is greater than or equal to 2. Because I have an equal to, then this circle is going to be closed, it's going to be solid. Alright? X greater, any number that is greater than 2. 3, 4, 5, to the right. So I graph to the right. I make my arrow. That's my arrow. Interval notation. Remember, any of these combinations, and the smallest value is going to be on the left. So every time you're writing the interval notation, what you do is you start sweeping from the left until you touch your graph. I touch my graph at 2. That's my smallest value. My highest value, it goes to the right forever, which is positive infinity. There you go. It's like an A sideways. And now, let me put my brackets. I have 2, it's closed, that's a bracket, it's included. For infinity, parentheses. My infinity will never be included. It always has either negative infinity or positive infinity. It always has the parentheses. Okay. Now, again, let's check the other notation for the other type of textbooks. Okay, here we go. My graph, my 2. All right, my 0. Because either instead of the closed circle, I'm going to use a bracket. So I'm going to put a bracket, put it to the right, and my graph is to the right. Okay? Here, big arrow. Alright, so either with a closed circle or with a bracket. Now let's do the set builder notation. Okay? So my set builder notation start with a brace. The set of all x such that, and I bring my inequality. X is greater than or equal to 2. Again, the set, we start with the brace, the set of all x, and the bar is such that x is greater than or equal to 2. The set of all x such that x is greater than or equal to 2. And we're done. Solve, graph, interval notation, set builder notation. Let's do a little bit more complicated. So we have this one now. Negative 3x plus 4 is less than or equal to 5x minus 12. Again, same thing as a regular equation. I have x's on both sides. My recommendation is that you always solve the same way. Most of my students like to have the x on the left side, so I want to cancel whatever is on the right. The first thing you do when you have variables on both sides is to cancel one of the variables. That will make your life much easier. So I'm going to cancel always what is on the right side. Is it 5x? So I'm going to subtract 5x on both sides. Minus 5x minus 5x. Negative 3 minus 5 is going to give me negative 8x. Bring down the 4 is less than or equal. 5x minus 5x is 0. Bring down the negative 12. Now the x is on the left. I solve for x. Cancel the 4. Minus 4 minus 4. 4 minus 4 is 0. Bring down the negative 8x. Negative 12 minus 4 is negative 16. Okay. Last step, divided by negative 8. And I divide on both sides. Whatever I do one side, I do on the other side. And here comes the problem with inequalities. When I divide or multiply by a negative number, I switch the direction of my symbol. It used to be less than or equal to, now it's greater than or equal to. When I divide or multiply by negative, I switch the symbol only when I divide or multiply. That's it. Only when multiplying or dividing. Not subtracting, not adding, multiplying, dividing. Negative 8 divided by negative 8 cancels out. That gives me a 1, right? I'll bring my x down. Negative divided by negative is positive. 16 divided by 8 is 2. And it came out to be a nice, easy inequality. Alright? Same idea. Let's graph. I place my 2. The 0 is on the left side. Alright? Because it has an equal, then my circle is going to be shaded or solid. And I read from the x. X is greater than or equal to 2. Greater, any value that is greater is to the right side. That's my graph. Interval notation. From the lowest value, in this case is the 2, is included. So I have a bracket to the right, infinity or positive infinity with the parentheses. The graph. The other option, instead of using the dot, I'm going to use the bracket. So I'm going to have a bracket opening to the right, right? This is a 2, and my arrow goes to the right because it's greater than. So that's the two choices for the graph. Set builder notation. The set of all x such that, and I bring my inequality. X is greater than or equal to 2. And I close the brace. The set of all x such that the bar x is greater than or equal to 2. Okay. Let's build another one. Let's do another one. Okay, so now we have a much more complex problem. Okay. But again, I just want to make sure that you guys understand that the idea is the same. Solve this as a regular equation. If you're dividing and multiplying by negative, then you flip the inequality symbol and that's it. So let's work on this one. Alright, before we start, guys, if you haven't subscribed to the channel, please make sure you subscribe to the channel and hit the notifications bell. After this video, we're going to do our next video is on compound inequalities and absolute value inequalities. Alright, and then we keep building on it. Alright, let's continue here. So every time I have an equation or an inequality with parentheses and a number on the outside, that means I have to distribute. That's my first step, distribute here too. So let's start from here from the left. 4 times x is 4x, 4 times negative 6, negative 24, and I bring everything else the same because that's not inside the parentheses. The other side, 3 times x, 3 times negative 7 is negative 21, and I bring down the 10x. Once I got rid of my parentheses, now I combine like terms on each side. You combine like terms on that side, and you combine like terms on that side. Alright? So let's say I have 4x and 2x, that's going to give me 6x. And then I have negative 24 minus 4, and that's going to give me negative 28. Alright. Inequality symbol. The other side. 3x plus 10 is going to give me 13x. And I'll bring down the negative 21 because that's the only number that I have. Now is the kind of the same problem that we have on the previous one. X on both sides. Cancel one of them. Either the 6x or the 13x, it doesn't matter. Okay, I'm going to stick to canceling the right side all the time. Minus 13x, minus 13x, and let's organize here this. 6 minus 13 is going to be negative 7x. Minus 28, I bring down the 28. Greater than or equal to 13 minus 13 cancels, bring down a negative 21. X is on the left side. Let's continue to work on the left side. I gotta cancel the 28. It's negative, so I add. Okay, plus 28, plus 28 on both sides. 28, negative 28 plus 28, 0. Bring down the negative 7x is greater than or equal to negative 21 plus 28, or 28 minus 21 gives me 7. All right, last step, divide by whatever is with the x. In this case, it's a negative. Look at that, I'm divided by negative. So my symbol flips. Instead of being greater than, turns into less than. Negative 7 divided by negative 7 equals to 1. All right, the 7's cancel, bring down the x. Be careful. You're dividing by a negative number, your symbol flips, switches. 7 divided by negative 7 gives me negative 1. And the x is by itself. Now let's graph. Number line. I place my number, negative 1. My 0 is on the right side. I always ask my students to show me the 0. Let's read from the x. X is less than or equal to negative 1. I go to negative 1, I put a circle right away, I come back to my inequality symbol, it has an equal underneath. I come back to my graph, I shade it because it has an equal. X is less than. Always less than is going to be to the left. Any value that is less than is to the left, greater to the right. So x less than negative 1 is to the left. What I'm saying is any values that are less than negative 1. So any of this will satisfy my inequality. Negative 2, negative 3, negative 4. Any of those values will satisfy this inequality. I graph in interval notation. I start from the left, right? So as you can see, I have an arrow. Because I had an arrow, this keeps going and going and going and going. So my lowest value is going to be negative infinity with a parenthesis, comma. My greatest value, here's when my graph stops at negative 1. There's no more graph to the right. So here my graph stops, and that's my greatest value because it's included, it's solid, it has an equal sign. I put a bracket. Let's graph the other way as well. Okay, in this case, it's to the left. It's starting at negative 1. Because it's included, I have a bracket opening to the left. And then I have my big arrow to the left. So this is all the values that are less than or equal to negative 1. The most common graph is this, but I'm just doing this just in case. So graph, inequality, set building notation. The set of all x such that, bring my inequality. X is less than or equal to negative 1. The set of all x such that x is less than or equal to negative 1. And I'm done. Solve, graph, interval, set builder notation. Alright guys, if you enjoyed the video, please subscribe, hit thumbs up, notifications bell so you get an alert when more videos are coming. And thank you for watching. I'll see you in the next one. Take care.